Hi everyone. So this is day 8 of 30 days of ML challenge. We have done till day 7, which was all about Python. So now we are going to jump on to machine learning. So the really first introductory part for machine learning is how models work. So in this day 8 chapter we are going to discuss about how models work, and after that we are going to check about basic data exploration. So these two modules are the part of day 8 of machine learning, right? So let's start with the introduction part. In this introduction, they have discussed about the models. What are machine learning models? They have given a really simple example here. But let's suppose that you have one cousin who has made millions of dollars, like on real estate, and now he wants you to become the business partner as a data scientist. So what he'll do is that he'll give you the money, and you have to supply the models to him that will actually predict how much various houses are worth. So this is one of the really important part about machine learning, that we keep on talking about the models and everything, that okay, this is the fanciest model, or this model is really great, or let's say we always talk about artificial intelligence, neural network and things. But again, the most important part at the end of the day is that how much business value your model is giving. So that's what we'll talk about here. But yes, let's jump onto this thing. The really basic and the first model they have discussed is decision tree. There are several models I believe you have heard. So let's say linear regression, KNN, Bayes model, like that. There are several models, and we will talk about that models in upcoming videos. But right now they have discussed about decision tree. So like we know about a tree, that a tree has a root node, and from that root node there are leaves. Similarly, in a decision tree, we have this root node, and then there are leaves of that root node. This is the most simple decision tree, right? So the question says that does house have more than 2 bedrooms? If yes, then definitely it has more price. If no, then it has less price. Really simple yes or no question. The most basic decision tree, right? It divides houses into two categories. The one with 2 bedrooms, more than 2 bedrooms, and one with less than 2 bedroom or equal to 2 bedrooms, right? And then it's giving us the predicted price. So the next part is about improving the decision tree. They have also discussed about that the step of capturing the patterns from data is known as fitting or training the model, and then the data which is used to fit this model is known as training data. So let's say that the real estate agent who is actually providing us data, he has this big Excel file from last 10 years in which he is saying that okay, these were the price in these particular areas. So this is our training data. From that, our machine learning model will learn and know that okay, this is the thing which happened in the past and this can happen in the future. So that is the training data, right? And this step of capturing the pattern from data is known as fitting or training the model. That's known as like fitting the machine learning model. We'll also talk about overfitting, underfitting, how these things can impact the model. But for now being, the step using which we capture the pattern from the data, that is known as fitting or training the model. So here we have two different examples in which they have actually given two different decision trees. So the first decision tree says that if a house has more than 2 bedrooms, then the predicted price is higher for as comparison to the house with less than 2 bedrooms. And the second decision tree says that if a house has more than 2 bedrooms, then that house is lesser in price as comparison to the house with less than 2 bedrooms. So if we really talk about the general intuition here, it seems that the first decision trees make more sense as comparison to the second decision tree, right? But how do we know this thing? Because we have a basic idea. We have some sort of, you can say, data feed inside our brain which know about this thing. But for machine learning model, we need to teach this thing, right? So how can we improve the decision tree? By adding more factors. So what they have done is like you can capture more factors using a tree that has more splits, right? So this decision tree is split into more than one, right? So this is a root node. After that we have no and yes. Then there are two different nodes. After that we have two more nodes. Similarly, we can add a lot more factors, such as whether a property or a house is located near the city or away from the city, whether is there any supermarket near the house or there is no supermarket near the house, what sort of weather it is, what sort of crime rate it is. So the more factor you add, the better your machine learning model will be. So this is a very basic thing about how a machine learning model work. So if I jump on to second part, we will discuss about how to use machine learning library pandas to get familiar with your data. So if you remember, in day 7 we discuss about importing the external libraries. So pandas is one of the most important and popular machine learning library which we definitely use to import the to do the data manipulation. So this is just some basic code in this code chunk which say that how can we actually read the CSV file. So you see PD, that means that from panda call this function name read underscore CSV, and after that we are actually passing it a file path, and then this is one more function known as describe. So if we like call this function, we'll get a complete summary statistics of the data like count, mean, standard deviation, minimum, and then IQ1, IQ2, like that. So this was about really basic thing about pandas. So let's jump on to our first coding exercise here. So in this coding exercise, let's see what sort of problems do we have. Right, so let me just run this code chunk. They are just importing some external libraries. If you want to learn more about these learn tools, they actually have a complete GitHub repo in which they have mentioned how these things are working. I'll share that link with you guys. But yes, so these are really important. Once it will print setup complete, we can jump on to the first question, which is loading the data using pandas. So if you know about pandas, similarly there are a lot more libraries such as matplotlib and then numpy. So these all are really important libraries in machine learning. So let's jump on to question 1. It says that read the IOWA data file into pandas data frame called home data. So this is the file path, right? What do we need to do here is we just need to call PD, that means panda, then we say give us this function which is read underscore CSV, and after that we'll just pass on the variable with the file path, IOWA file path. We'll just run this code chunk. Yep, it says that it is correct, perfectly fine. We'll jump on to the step 2 here. Step 2 is review the data. So we need to print the summary statistics in this line. So as you know, how we can print the summary statistics is just call the variable with the data. So the variable is home underscore data, and then we need to call a function named describe. So this describe function will give us the summary statistics, right? Total count, mean, standard deviation, minimum 25%, 50, 75, and max. Now let's jump on to next question. It's saying what is the average lot size? Round that to nearest integer, right? So let's see, mean means average. We need to know about lot size. So if you know this column lot area here, so the lot area, the mean of against lot area is 10516. If we round it to nearest integer, we'll write it 10517, right? So this is lot area. That's what they are asking, that what is the mean lot area. Mean lot area is this 10. We round it to nearest integer. As of today, how old is the newest home? So what we need to do is we need to subtract the date in which it is built from the current year. So right now it's 2021. Let's find out the home age. Let's see what sort of variables do we have here. Wood tag, open porch, enclosed porch, pool area, month sold, year sold, right? So what we need to do is we need to find how old is the newest home. So if you look at all these years, the newest home is built in 2010. So we'll just subtract 2021 from 2010. That will be 11. 11 is the number. How we did it? Right now we are in 2021, and we'll subtract this 2010 from this. I'll just comment out this thing. Right, so this is question 2. Let's check. Yep, correct. So this was all about day 8 of machine learning challenge. I'll come back to you with day 9. Thank you very much.